Well, thank you very much, everybody, for taking some time out of your afternoon to hear about what's new in Parkinson's disease. I've put together about a 40-slide talk covering what I think are important areas for Parkinson's disease, both in terms of basic research and also in terms of practical treatment issues for doctors and other clinicians who take care of Parkinson's patients. And I have it divided, as you can see in the, it's going to be for the first content slide, into four basic areas: genetics, non-motor problems, early detection, and treatment. And I think that the treatment's broken into timing of initial treatment, deep brain stimulation, and disease modification, which is sort of a shorthand for neuroprotective therapies. We'll probably spend a little more time in that area than the others. So why don't we get going with the first genetics slide? So genetics is a really rapidly evolving area in Parkinson's disease, as it is in all areas of medicine. It's about 12 years ago now that the first gene related to Parkinson's disease was identified. If the gene, a defect in the alpha, mutation, I should say, in the alpha-synuclein gene was identified in a large Greek-Italian kindred. A lot of the individuals actually live close to here, I live in Philadelphia, close to here in Philadelphia and in New Jersey. And a lot of the detective work was done by doctors at Barbara Wood Johnson Medical Center in New Brunswick, New Jersey. It turned out that it was a relatively rare gene. There's really only been a small handful of families who have alpha-synuclein genetic abnormalities. But it did open the door for this era of genetics in Parkinson's disease, and it's really seen the pendulum shift from what was thought to be really a non-genetic disease to a disorder where there's a recognition that there's a large, although very complicated genetic component. And now by 2008 and 2009 now there are a number of genes, probably 15 or so, which have been associated with Parkinson's disease, and the phenotypes associated with those genes, and also the actual gene products that the genes code for are being deciphered. And that's really the active work that's going on right now. And so there's one called Parkin, which is important, but only for early onset Parkinson's disease. There's another one called LRRK2, which you might hear about a little bit, which is probably responsible for probably between 1% and 5% of hereditary cases in the United States. And in some isolated ethnic populations, like North African Arabs and Ashkenazi Jews, it may be responsible for up to a quarter of familial Parkinson's disease. So at least this one gene, LRRK2, is actually epidemiologically important, and it's possible to identify large numbers of people that are LRRK carriers. It's sort of an interesting thing. You've probably heard of that the founder of Google, Sergey Brin, was gene tested himself because his mother has Parkinson's disease, and there's a LRRK2 mutation in his family, and his wife has a genetic testing company called 23andMe, and they're launching a large nationwide web-based program to get people with Parkinson's disease tested to see how many actually do have LRRK2 mutations. This slide you're looking at here shows a cumulative incidence of Parkinson's disease among 36 people that have the most common LRRK2 mutation. And the thing that's really important here is if you look over at the vertical axis, you can see the penetrance, which is the likelihood of getting the disease. Even up to age 90 is only about 50%. So this is a gene with incomplete penetrance, which means that at least half the people that are gene carriers are never going to get Parkinson's disease. And this is a relatively common motif in the genetics of late life disorders, that a lot of people that are gene carriers never get the disease. So it makes genetic counseling very complicated. And even at like age 80, which is sort of a typical age of sort of the life expectancy for people, you can see that the penetrance is more like 30%. So even though person would have this gene, it doesn't mean they're going to get the disease. And it just sort of illustrates the complexity of talking to patients about the genetics of Parkinson's disease.